Hi everybody. In this video we're going to look at two things: session variables and encrypting passwords. Session variables allow us to keep track of who the user is, to keep track of the session. So it would allow us to do something like this. Let me just go to Amazon here. So Amazon knows who I am and knows how many items I have currently in my cart. If I click here and look at this nice Paperwhite, it still keeps track, so I can visit a bunch of pages here, different pages, and it keeps track of who I am, how many items are in my cart. I can add, well, I don't want to customize that, but I can add items to my cart. Let's get to another item here in the list. Let's say I'll shop at the plain old Kindle. Add that to the cart. No, I don't want any of that stuff. So, and it keeps track of these from page to page. It remembers who I am and how many items are in the cart. This is interesting because by itself, HTTP is a stateless protocol. So without us doing anything, HTTP has no way of knowing that when I click on one page and then click on another page, that it's me doing the two clicks, it's the same person, rather that it's me doing the click to one page and you doing a click to someone else. So there's no way of maintaining state between two transactions. So there's really no, in HTTP by default, there's no way of really doing what Amazon wants to do. We have to be doing something special. We have to code it ourselves. So let's see how to do that. So here I'm back to the RC Club page. I've added a little login feature. I'm not doing passwords right now. We'll do that later. But I can put in a person's name and a plane. I want to hit a submit button. And then I want to be kind of friendly. I want to make people think that we care about them. So I'm going to put their name and plane up here in the menu bar, regardless of what tab I click on, what page we're visiting, just so they know, hey, we know you're Ann. We like you. So let's see how to go about and do that. So here's the index HTML page, the page that renders what I just showed, or the template that renders what I just showed you there. And here's the little form I made, right? So there's two text fields, one for user, one for plane. There's a submit button. When a person hits submit, this code gets sent to whatever's handling, or this form gets sent to whatever code is handling that slash. In server PY, I've declared two global variables, username and user plane. Right now they're the empty strings. Here's the code that handles that slash that the form gets sent to. I say up here that I'm using the global variables that I just talked about, username and plane. I check if the user pressed that submit button, did they get here by pressing submit? If so, set the username to whatever name they typed into the form, and set the user plane to whatever they typed in the form. A little later down here, I say user equals the list, username, user plane. So I just made it a little more convenient and made one thing. And then when I pass things to the template, I also pass that list. And I do the same here. So in the officers page, I say there's some global variables. I create this user with the username and user plane and then pass it to the template. Here's where it gets realized. Let me find that. It's right there. So user 0 is the username. So it's going to be username : whatever plane they're at. So that's my attempt at doing what Amazon does, keep track of users. So let's see how all that works. So here I have Ann. And here my plane is the UMX Radian. I like that plane. I didn't get the Radian bit. And let me scroll down to hit the submit button. And now up here, we see it says Ann UMX Radian. That's cool. Let's take a look at Club Officers. Same business. Hey, it looks like we're getting somewhere. FPV Lab. So we're good here for Ann. Let's try it with another user. So I'm going to switch browsers here. So here's my Safari browser. Here's the RC Club page, the same place I've been going. So now I'm going to have someone else log in, Ben. And Ben really likes the Easy Star. I'm going to submit that. Great. So here we have Ben liking the Easy Star. Club Officers, FPV Lab, everything looks really nice. Here I'm back at Ann. club officers. Oh, it switched to Ben Easy Star. So here I'm logged in, I thought as Ann, and all of a sudden now I'm Ben. The reason is this. We have one code that's executing, one executable, and lots of people are using this code. It could be thousands of people logged into our site. So using global variables here, the last person that logged in, the global variables were in server, the last person that logged in would be the person that everyone is. So obviously this is not the way to do it. It might be useful for some other tasks, but not for this task. Let's see how we can do that. How we do that is using session variables. Session variables are a way of keeping state, so doing what Amazon does, or doing what most modern websites do. They're stored on the server side, not in the browser. So if we know something about cookies, we can store information in cookies, but that's a browser side thing. Session variables are server side. They persist across multiple pages. That's exactly what we want. There'd be little use for them if they didn't. And unlike cookies, there's no expiration date. They die when the session ends. And the session can end if we close the browser. And cookies can persist if we close the browser. That's sort of the good and bad about cookies, right? So they create a security problem because of that, but they make life convenient. You know, you close your browser, you open it up the next day, and bam, you're in Gmail or you're somewhere else. I have my cookies expire always when I close my browser for safety, but it's not as convenient. So session variables are different. Using them is actually fairly straightforward. So we start a session this way, so only once in our code we put this in, so we're importing the session module, and then we add this line about the secret key. The secret key is how a cookie is signed. So to implement session variables behind the scene, we don't do this, but this is how it works. There is a special key, a cookie, that keeps track of who we are. So all the important information is stored server side, but this cookie is not. It's the thing that identifies this person is from this session. And this is just a big random number. So let's go ahead and put that in on the server side. So here from Flask, in addition to importing all this stuff, I'm going to import session. Here I've also imported OS, that was part of the deal. And here I'm created the app, the Flask. And now I'm going to say app secret key equal. So now I'm going to generate this secret key. And whoops, sorry, I didn't get the dot. Encoded as hex. And that looks great. And I didn't get any errors there. So I've done this step. And now using them is very easy. It's just like using a Python dictionary. The session variables are stored in a dictionary called session. So we can set them like this, and we can use them just by referencing them. So let's see how we can change the code I just had there by using these session variables. So that was here. They're not going to be global variables anymore. So instead of setting this global variable from this, I'm going to set a session variable. Session username equals request form user. So if they press the submit button, I'm setting some session variables. And now I need to change this bit here. So first I'm going to see if those session variables are set or if they exist. So I'll just say if username in session. So that means if it is, that means that those variables are set. So then I'll just type from scratch. User equals session username. What did I do? I didn't want this. Sorry, I screwed up. Let me fix that. Typing without thinking. All right, that sure looks a lot better. So the user is going to equal session username, session user plane. That looks good. So if it isn't set, I'll just say user equals the empty strings. Right, so if those variables are set, use them, else they're not going to be there. Actually, I need that then for, no, that would have not been good. Let me get rid of this. And get rid of this now. So I'm doing this for all the pages. I'll just do a few pages here. Whoops. Trying to line those up a little. I think they look aligned. Same thing here. So I'll stop with these. All right, that worked. And I believe I did it correctly. Well, let's give it a shot. Let's go to home. Well, that's encouraging. Nothing bombed out yet. All right. And UMX Radian. So now I get and UMX Radian up here. That's good. Let's just check. It's on the pages. I think I did it on this page as well. Cool. All right, now let me get my, that's not it, sorry. Let me hit the right thing here. There we go. And let me just refresh this page. And it's empty because we didn't log in with the new version. Now Ben. And I have Ben Easy Star up here, and club officers, FPV, back home, everything looks good. Now here's where we had the problem before, but let me go home, and I still have Ann here. So using session variables can keep track of things from page to page per user or per browser. So this is really important. We're going to want to do this if we're going to implement something like a shopping site, or people are logging in for doing something like a Twitter type thing. We would need to use something like this. So that was session variables. Okay, let's switch to talking about passwords. And to do this, I'm not going to be looking at Flask, but I'm just going to work with Postgres directly just to keep things clear. So let's get into Postgres here. Let me make this bigger. So it's PSQL, my user, my password. All right, let's take a look at those databases I already have. Let's switch into music. And now let's take a look at what tables there are in music. So there's just albums in music. Suppose I want to create a users table so I can allow users to log in with a password. So let's do that. And I'll have a username, which is type text. Text is specific to Postgres and a few other databases. It's very similar to varchar, except you don't need to specify the length of the field. It just assumes a very long field. There's no performance difference really between using text, using varchar or varying characters, or using characters or char. If anything, the performance is a little bit slower using characters simply because you need to do that padding, but there's no performance hit by using text, and it's sort of a nice thing to use, so I'm using it here. I'm also going to have a password here. That looks good to me. And now let me insert into this users table the values, and she has the password change me. And I'm going to insert Ben here, and he has the password 1, 2, 3, 4, 5, 6. And let's just make sure, double check that I have these in there. So here I just did a select statement. I have the people I inserted and their passwords. And what's important to look at here is that I have the passwords. You can read the passwords. So I know if I work at this company what Ann's password is. If I could read what Ben's password is. And if I get fired, I hate this company, all of a sudden hate the company, I can just take all these with me and release them on the net and just just because I'm angry, right? So this is really a bad idea from that perspective, that people at the company have access to the passwords, and it's bad for other reasons as well. So here, let me switch to this one first. This is just last year, 10 million stolen passwords were released. See if yours is one of them. And that thing I just flashed a second ago, all these other accounts of passwords being stolen, and you'd feel really, really bad if you were like a new hire and your code contributed to having all these passwords stolen. So it's really not a good idea. In fact, it's a really, really, really bad idea to store passwords what's called in the clear. In the clear meaning I can look at the database and see what the passwords are. Instead, the correct approach is to hash these passwords. Hashing is one way. It changes the password I type, like the password changed me into this kind of gobbledygook long string I can't reverse really, or it's very, very difficult to reverse. So that's what we'd like to do here. We're gonna, instead of having change me, we're gonna have a long string. We're gonna hash this word into something that's not very decipherable. So first, let me show you, let me get out of this, go to my README. So here's the summary of what we'll be doing in the remaining few minutes of this video. So we're gonna be hashing passwords. The first thing we need to do, and we only need to do this once, is to install the package that will enable us to do it in Postgres. Then for every database, so when we create a database and we're going to have a user and we're going to store some passwords, we'll need to do this step, enabling hashing within the database. The next step is when we want to insert values into the database that we want hashed, how to do that actual hashing. So we'll take a look at that. And as you can see, just for an 8-character lowercase letter password, it would take 246 years to crack on a standard PC. And if we allow lowercase letters, uppercase letters, and 0 to 9, it would take 251,322 years to crack. Of course, if your password is 1, 2, 3, 4, 5, 6, smart people would just sort of guess that. Or if your password is the name of your dog, then who cares how good the hashing algorithm is? You're just making a silly mistake by making an easy to guess password. This approach isn't going to help with that problem. Finally, when a person does try to log in, we'll see how to go check and see if that password that they typed is the correct one. So let's get started here. So the first step is to install that package. To do this, I need to be out of the database. And let me just finish typing and not talking. This will look slightly different for you. I uninstalled my Postgres Contrib 9.3 and then am reinstalling it just for demo purposes. So the interface or the text that you'll see will be a little different, but this is basically what we'll need to do. The difference will be, well, let me just run this and tell you what the difference is. Okay. The difference is, in mine, it just did it. In yours, it'll probably ask a yes/no question. It's just going to take X amount of space. Are you sure you want to do it Y or N? So for me, it just worked. The second step is enabling hashing within the database. So let's stick with our music example. And in order to do this, let me just kind of make that whole interface big. Let me log into the database server. Let me change into music. Let me just get a reminder of what that looked like. Okay, those are the ones in the clear. So the first thing I mentioned is that for each database that we want to do this on, we need to use that extension. So it created that extension. And now here's how to insert a person and their password into the database with hashing that password. This looks just like we did before. And I want to, oops, that's not good. Gonna insert Clara here. And her password is, before we would just type something like foo-foo, if that was her password. Instead, what we're going to do is we're going to cache it doing this crypt function. And let's say our password is password. And now we're going to generate a salt. A salt is a value that gets appended to the password before the final hashing takes place. And there's a really good algorithm called Blowfish. That's the one we're going to use. It generates a salt by doing multiple loops through the hash. Let me just get the general. I think that's enough. Closing parentheses. Let's hope. Yes, I think it is. All right, so let's do that select statement again. And now we see that the word password here gets encrypted by this very long value. That it'd be hard to look at that and say, hey, that's the password. Let's insert another, let me just do it from scratch here. And let's say Dora's password is, both of these people are about the same, and their passwords are the same. It's the string password. Okay, I think that looks good. And now let's look at these two. You see that these are different. So even though the password is the same, password, these two are different. That's the function of the hash. And it's nice. So if you say, oh, I know Clara's password is password, so Dora's, there's no way of really saying, oh, well, so then Dora's password must be password, right? Since they're different, it's hard to do any kind of analysis of, who has similar passwords. Or the most common password is this long string, and one of the more common passwords might be 1, 2, 3, 4, 5, 6 or whatever, so we could just kind of do testing that way. Here, there's no way of knowing what that is. Finally, let's say someone wants to log in, and we get some values from that form, and let's see if they're good ones. Whoops. So here they typed in the word password, and we're going to compare it to the password that was stored in the database. And we get both in this case, right? So we know that Clara's password is password and Dora's password is password. But if a person logs in, well, let's just do it over here. And username equals Clara. And now we just get Clara back. So we would use something like this to check whether a person typed in the correct password. So there, I showed you the big thing to keep in mind is never, ever, ever store passwords in the clear, meaning, well, I guess this is up here. This would really be bad practice to have passwords in the clear. Much better to use a hash function that'll convert those passwords into something that's not recognizable in the database. Again, even so, if someone breaks in, grabs those passwords, it doesn't do them any good. They can't read them. And also, if there is some disgruntled employee gets fired, whatever, they don't really have access to the passwords either. So it's really a nice way of doing stuff. So I hope that helps and explains a few things, the session variables and passwords. Happy coding.